We are going to see now vibrations of an air column in a pipe closed at one end. That means we are going to see how the longitudinal stationary waves are set up along the length of the pipe. If we consider a long cylindrical tube, suppose this is a long cylindrical tube, this tube is closed at one end. Now this acts as a pipe closed at one end. Here, when a vibrating tuning fork, if we held the vibrating tuning fork near the open end of this resonance, tube or this cylinder, then what happens? Here, if we held the tuning fork near the open end of this pipe, sound waves are sent by the fork inside this tube. As you can say that longitudinal waves are traveling along this pipe and are reflected back at this end. Here, as the vibrating tuning fork is held near the open end of this, then it travels inside this pipe. At this closed end, they get reflected back. That means because of incidence and a reflected wave, that is incident and reflected wave, they coincide, so they superpose with each other, giving rise to the air column. The phase reflected, that depends on whether the end of pipe that is closed or it is open. Now, when it is closed, at this end the particles are not free to vibrate and therefore they get reflected back at this closed end. At the closed end, there is least particles for the motion of the particle. There is a very small freedom, and therefore there must be the node is formed at this closed end. And you know that in case of pipe closed at one end or open at both ends, the boundary condition is that there should be node is formed at the closed end while antinode is formed at the open end. And therefore here, that the closed end, the node is formed. The particles beyond the open end are more free to vibrate as compared to that of this closed end. Here the particles are more free to vibrate and therefore here antinode is formed. Now, how the air column get vibrate in different ways, that we are going to see. The first mode of vibrations of an air column in a pipe closed at one end, that is shown in this diagram here. With the help of this diagram, we can explain that. This is the first mode of vibrations of an air column in a pipe closed at one end. As you can see that a vibrating tuning fork is held near its open end. Here you can see that the length of antinode is formed here at a little distance beyond it. Now this is small l, this is the length of air column, and now see here, this is capital L, correct L length. Capital L is equal to small l plus end correction, and that capital L is equal to here, you know that this is the first mode of vibrations of an air column in a pipe closed at one end. Here, now this is the antinode is formed here and node is formed here, and you know that distance between node and its adjacent antinode is lambda by 4. Here lambda be the corresponding wavelength. Here the length of this corrected length of this air column is equal to L by 4. This is the simplest mode of vibrations of an air column in a pipe closed at one end. This is also called as the fundamental mode of vibrations of an air column in a pipe closed at one end. Here you can say that length of air column L is equal to lambda by 4. Therefore, lambda is equal to 4L. As you know that V is equal to N lambda, we want to find out the frequency, fundamental frequency, and therefore N is equal to V by lambda. As N is equal to V by lambda, then you can write N is equal to V upon 4L. Or you can write N is equal to V upon 4 into L plus E. This is the first, in this way, the air column can vibrate with frequency N is equal to V upon 4L. This is the fundamental frequency of mode of vibration. This is the simplest mode of vibrations of an air column in a pipe closed at one end. This is also called as the fundamental frequency of vibrations of an air column in a pipe closed at one end. This is also called as the frequency of first harmonic. This is also called as the frequency of first harmonic. This is the first mode of vibrations of an air column in a pipe closed at one end. Here, if the question is asked on this topic, that is, you have to show that how the odd harmonics are present in case of pipe closed at one end. At that time, with the help of the diagram, you have to explain that, and at that time, the diagram carries half mark, and this explanation for half. That means half it will be 1. This question can be asked for 3 marks, and therefore each diagram for half mark and half mark for its derivation. Therefore, you have to remember that you have to draw the diagram neatly. And the fundamental frequency, you have to remember this formula is very important. The fundamental frequency of vibration of an air column in a pipe closed at one end is n is equal to V upon 4L. Related to end correction, we have written that n is equal to V upon 4L plus E. Now, the air column can vibrate. The next mode of vibrations of an air column in a pipe closed at one end, that is shown here. There is also antinode is formed at this end. I have not shown the tuning fork. Here, this is the mode of vibrations of an air column. Next mode of vibration. Here, antinode is formed here. Antinode, node, antinode, node. Here, two antinodes and two nodes are formed. Here, length of air column. This is small l. Capital L is the antinode passenger. Capital L, that is the corrected length. And small l, that means length of air column. And that will be smaller. Now here, in this case, the length of air column L is equal to 3 lambda by 4. This lambda by 2 plus lambda by 4. That means it will be equal to, you can say it will be 3 lambda by 4. Here you can say that lambda 1 be the wavelength in this case and n1 be the frequency. Then this is the second mode of vibrations of an air column. Then in this case, length of air column, it will be equal to 3 lambda 1 by 4. Therefore, lambda 1 is equal to 4L upon 3. We want to calculate its frequency, therefore V is equal to, you can see it will be equal to n1 lambda 1. And therefore n1 is equal to V upon lambda 1. And that will be equal to n1 is equal to V upon lambda 1. That means it will be 3V upon 4L. That will be n1 is equal to 3V upon 4L. This is the second mode of vibrations of an air column. This is called as in this case here, you can write, this is the frequency. You can write, this will be equal to, n1 is equal to, as you know that, 3n. Because n is equal to V upon 4L. Therefore, n1 is equal to 3n. This is the frequency of third harmonic or the frequency of first overtone. That is, n1 is equal to 3n. This is the frequency of third harmonic, or you can say that it is the frequency of first overtone. That means now here, the second mode of vibrations of an air column, that is shown in the diagram. Length of air column is equal to 3 lambda 1 by 4. Here lambda 1 is equal to 4L by 3. V is equal to lambda 1 be the corresponding wavelength. Therefore, V is equal to n1 lambda 1. n1 is equal to V upon lambda 1. And therefore, n1 is equal to 3V upon 4L. We have substitute value of lambda 1 here. Then you get 3V upon 4L. That means it will be equal to 3V upon 4L plus E related to end correction. And then you can write n1 is equal to 3n. This is the frequency of third harmonic, or it is called as the frequency of first overtone. Here, this is the second mode of vibrations of an air column in a pipe closed at one end. Then, the third mode of vibrations of an air column in a pipe closed at one end, it will be shown in this diagram here. This is the second mode of vibration. Here, antinode is here. Antinode, node, antinode, node, antinode, node. 1, 2, 3. 3 nodes and 3 antinodes here will be formed. In this case, small l be the length of air column. Capital L be the length, which will be equal to now 5u. Lambda 2 be the corresponding 5u lambda 2 by 4. The length of air column L is equal to 5u lambda 2 by 4 here. Here, this is the third mode of vibrations of an air column. In this case, length of air column is equal to L is equal to 5u lambda 2 by 4. Lambda 2 be the wavelength and N2 be the corresponding frequency. Then you can say that lambda 2 is equal to 4L upon 5u. You can write it will lambda 2 is equal to 4L upon 5u. Corresponding frequency, you can say V is equal to N2 lambda 2, where N2 be the frequency. Then you can write N2 is equal to V upon lambda 2. If we substitute this, then you get N2 is equal to, that means it will be 5u V upon 4L. That is here. You can write N2 is equal to 5un. N2 is equal to 5un. This you can write it as 5u V upon 4 into L plus A. Remember here, capital L, that is the corrected length, and small l be the length of air column. This is the third mode of operations of an air column. The length of air column is equal to L is equal to 5 lambda 2 by 4, where lambda 2 is equal to 4L by 5. As you know that lambda 2 with the wavelength and N2 with the corresponding frequency, then V is equal to N2 lambda 2, and therefore N2 is equal to V upon lambda 2. If we substitute the value of lambda 2 here, then you get N2 is equal to 5uv upon 4L. In terms of end correction, you can write it to be 5uv upon 4 into L plus E. This you can write N2 is equal to 5N. This is the frequency of fifth harmonic or second overtone. See again here, this is the frequency of fifth harmonic, or this is the frequency of second overtone. In this way, the air column can vibrate with the frequencies of only odd harmonics that we have seen. That is here, as we have seen that the air column vibrate with frequencies N, 3N, 5UN, etc. This is the fundamental frequency, or it is called as the frequency of first harmonic. This is frequency of third harmonic. This is the frequency of fifth harmonic. This is the frequency of first overtone. This is the frequency of second overtone. That means here, it consists of only odd harmonics. And therefore, the frequency of pth overtone will be Np is equal to 2p plus 1 into N. This is the frequency of pth overtone. If we want to find the frequency of pth overtone, they can use the formula Np is equal to 2p plus 1, where p is equal to 0, 1, 2, 3, etc. 0 ठेवला तर 2 into 0, that means frequency of first will be equal to, this is the 2 into 0, that means it will be equal to N. Here you can see it will be equal to, it will be p is equal to 1, 2, 3, Then if we substitute the first overtone frequency, find out correction, 2 into 1 plus 1, that means 2 plus 1, that will be equal to 3N. This is the frequency of first harmonic, therefore p is equal to 1, 2, 3, 4, etc. And then you can find the frequency of pth overtone. Here, Np is equal to 2p plus 1 into N. In this way, if question is asked like this, then you can find here how the odd harmonics are present in case of pipe closed at one end. You have to show that only odd harmonics are present in case of pipe closed at one end. That is, frequencies present in this case are N, 3N, 5N, etc. This is the frequency of first overtone. This is the frequency of second overtone, etc. This is the frequency of first, that is the pth overtone. You have to remember Np is equal to 2p plus 1 into N. Here you have to remember this. Then you have to show that how the odd harmonics are present in case of pipe open. We have to find out the end correction in this case. In order to find out the end correction, then you know that the fundamental frequency for vibrations of an air column, that N is equal to V upon 4L. This we have seen. N is equal to V upon 4L. Therefore, you can write it will be equal to V is equal to 4N1L1 is equal to 4N2L2. In order to find out the practical formula for end correction related to closed pipe, this is the fundamental frequency. Therefore, V is equal to 4N1L1 is equal to 4N2L2. This you can write N1L1 is equal to N2L2. This you can write N1 is equal to L1. That means L1 plus E is equal to N2 into L2 plus E. This is related to end correction. And when you solve this, you get E is equal to N1L1 minus N2L2 upon N2 minus N1. This you can find the end correction. E is equal to N1L1 minus N2L2 upon, 2 into N2 minus N1. Or you can write this as N2L2 minus N1L1 upon 2 into N1 minus N2. This will also be E is equal to N2L2 minus N1L1 upon 2 into N1 minus N2. With the help of this formula, we can find out the end correction related to the pipe closed at one end. In this way, we have seen the how odd harmonics are present in case of pipe closed at one end and how to find out its end correction with the help of this formula. You have to remember this formula is very important for your objective as well as CAT. You have to remember this is the fundamental formula, fundamental frequency of the closed pipe, that is equal to V upon 4L.